So guys, in today's video we are going to learn about physical properties of ethers. What's that? Physical properties of ethers. Of course, when we were dealing with the haloalkanes, haloarenes, alcohols, phenols, there also we have seen the physical properties. And whenever we were dealing with the physical property, of course we were mainly focusing on two important things. What were there? One was the boiling point of the respective compound and another was the solubility of the respective compound in water. In the same case, here also we are going to study the physical properties of the ethers under these two criteria. One will be the boiling point of the ethers and another will be the solubility of ethers. So before starting the boiling point of the ethers, let us first of all deal with its general representation. That is, whenever we write as an ether, we write it in this way, ROR. Yes or no? So of course, if I take an example, I can take as a methoxymethane. Let me take as an example as a methoxymethane, CH3OCH3. So generally we write it in this way. But actually yav atom bond agirutte, which atoms are bonded, we should write it in this way so that we will be understood properly. So this is the way of representation of our ethers. What is the main difference between the two? Of course, generally in all the books, whatever if we say to write ethers, we write it in this way. Methoxymethane baridi andre ide riti baritivi. Adre ee riti bardaga, when you're writing the second example, okay, methoxymethane, a second representation nodaga, we'll get a proper image that which bond is bonded to which atom. Alva? Illi navu tilkuntive enanta hydrogen is bonded to oxygen. No, that is not the case. What we have to remember, whatever the ethers we are talking, they are mainly the bond existing between the carbon and the oxygen. I repeat, whatever the bonding in ethers is present is between that of your carbon and the oxygen. Okay, so if somebody were knowing it initially, why is it necessary to deal with that of your boiling point will be the question. Alva? So remember, when we are talking about the boiling point, many times I have said the polarity matters a lot. Alva, if there is a highly polar means there will be some changes. If they are non-polar means there will be some changes. The same changes will be observed over here. But of course we know that such a polarity will be existing depending upon the bond which is present between the different atoms. So in ethers, when we see that bond representation, we came to know that whatever the bond which is existing is in ether is mainly between that of your carbon and oxygen. I repeat, whatever the bonding which is present in the ether is between that of your carbon and oxygen. And we know these two atoms are having a different electronegativity values. I repeat, these two atoms, as carbon and oxygen, will be having a different electronegativity values. But when we check the difference between the electronegativity values of these two atoms, of course we know that oxygen is highly electronegative, whereas compared to that of your carbon. So there exists a dipole. There exists a dipole. That is, oxygen will be having one polarity, carbon will be having another polarity, that is negative, positive. Two poles will be existing. So name called as what? Dipole. Are you getting my point? Of course, now we came to know whatever the bond which is existing between C and O is a polar, and hence they will be having a dipole moment. They will be having a dipole moment ಅಂತ ಬರುತ್ತೆ ಅಲ್ವಾ? ಯಾವತ್ತೇ ಒಂದು ಬಾಂಡ್ ಪೋಲಾರ್ ಆಗಿದೆ ಅಂದ್ರೆ ಅರ್ಥ ಏನು, ಆ ಒಂದು ಬಾಂಡ್ ಅಲ್ಲಿ ಡೈಪೋಲ್ ಮೊಮೆಂಟ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ. But do remember, whatever the boiling point we are going to see or whatever the boiling point we are going to compare, it merely does not depends upon this dipole moment. Or we can say in simple words, this dipole moment is not going to affect the boiling point of ethers. The boiling point of ethers. So So that is the reason, now comes the main part. That is the reason when we see alkenes and ethers of comparable molecular mass, they will be having comparable boiling point. Sir, I didn't get what did you say. Then let me say it once again. So of course what we came to know when we are seeing the ethers, of course there is a bond polarity exists due to the higher electronegativity difference between that of your carbon and oxygen. Whenever there is a bond polar, of course there exists a dipole moment. But do remember, this dipole moment in ethers, more specifically I am saying this dipole moment in ethers is not affecting the boiling point. When I have compared the alkanes and ethers of comparable molecular mass, I came to know that there is a comparable boiling point. Of course, alkanes ಅಲ್ಲಿ ಯಾವ ತರದ್ದು ಬಾಂಡ್ ಪೊಲಾರಿಟಿ ಎಕ್ಸಿಸ್ಟ್ ಇಲ್ಲ, ಸಿ ಮತ್ತೆ ಹೆಚ್ ಮಧ್ಯದಲ್ಲಿ ಅಷ್ಟಾಗಿ ಏನು ಬಾಂಡ್ ಪೊಲಾರಿಟಿ ಇಲ್ಲ, ಹಾಗಾದ್ರೆ ಡೈಪೋಲ್ ಮೊಮೆಂಟು ಇಲ್ಲ. ಆದ್ರೆ ಈಥರ್ಸ್ ಅಲ್ಲ ಡೈಪೋಲ್ ಮೊಮೆಂಟ್ ಉಂಟು. ಸೊ ಏನಾಗ್ಬೇಕಿತ್ತು, ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಇರ್ಬೇಕಿತ್ತಲ್ವಾ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್, ಬಟ್ ಇಟ್ ಇಸ್ ನಾಟ್ ದಿ ಕೇಸ್. ಸೊ ಅಲ್ಲಿ ನಮ್ಗೆ ಏನ್ ಹಿಂಟ್ ಸಿಗ್ತಾ ಉಂಟು, ಆಫ್ ಕೋರ್ಸ್ ಇನ್ ಈಥರ್ಸ್ ದೇರ್ ವರ್ bond polarity was there, and of course it was having a dipole moment, but the dipole moment is not affecting the boiling point in ethers. Why I am saying this, if I take an example of that of your N-pentane and ethoxyethane, N-pentane and ethoxyethane. What is the formula for N-pentane? Alva, CH3, CH2, 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 CH3. 1, 2, 3, 4, 5. N means normal, means straight chain. Pent means 5 carbon atoms. A means it's belonging to alkane homologous series. Ethoxyethane, how can you write? Alva, C2H5O C2H5. So first let us check out its molecular formulas. How many carbon atoms? 1, 2, 3, 4, 5. So 5 carbon atoms. Each carbon atom is having the molecular mass of 12 mu. Yes. So 12 into 5 will gives you 60. Then what about your hydrogens? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. What you can say? 12 hydrogens into 1. So that is equal to 12. So totally I am getting for N-pentane the molecular mass is equal to 72 unified mass. Alva. Coming with respect to your ethoxyethane. Okay, here I should write a H alva. Okay. Carbon. How many carbons? 2 to 4. 4 into 12. So how much? 48. Similarly 5 plus 5, 10. Hydrogen. So 10 hydrogen into 1. So 10. Oxygen is also there, so 1 oxygen means 16 into 1, that is equals to 16. So how much you are going to get? 74. Alva. Yes or no? 6, 6, 12, 13, 14, 4, 1, 5, 6, 7. Yes or no? So totally 74. You can just check it out. So it is 72, it is 74. Nearly equal. Nearly equal. I am not saying that exactly equal. They are comparable. Alva, they are comparable. So when I was having a normal alkane, that is your N-pentane and ethoxyethane, there is an alkane and an ether. Alkane and an ether of a comparable molecular mass. When I checked their boiling point, I observed that your N-pentane is having the boiling point equals to nearly 309 Kelvin. How much? 309 Kelvin. Coming with respect to the boiling point of ethoxyethane, what I was observing is it is having nearly in the range of 307 Kelvin. 307 Kelvin. So this was the reason which I came to know that even though your ethers are having a polarity, bond polarity, but whatever the dipole moment which is existing due to this bond polarity is not having the effect on the boiling point of the ethers. This was the first important thing. But I didn't stop over here. What the scientists did, of course, when we were checking the comparable molecular masses of alkanes and ethers, we came to know. But what if I check the functional isomer of an ether, that is an alcohol, was the another question. So what they did, now they compared your ethoxyethane C2H5O C2H5 with butane 1-ol. What is that? Butane 1-ol. That is CH3, CH2, 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 OH. Yes. You just check it out. Of course, we know here the molecular weight of your ethoxyethane, we have got what? 74. What about this one? Your butane 1-ol. 1, 2, 3, 4. Yeah, 48. 12 4s are 48. 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogens plus 1 oxygen. Of course, it is also having 74. Alva. So what can remember? It is a functional isomers. Ethoxyethane is also having 74. Here exactly equal they are. Alva. Illi nodi molecular weight exact agi equal untu. So your ethoxyethane and butane 1-ol. Butane 1-ol are functional isomers. Idರಲ್ಲಿ ನಮಗೆ ether untu, idರಲ್ಲಿ ನಮಗೆ alcohol untu. So when I considered these two as an example, of course it was a surprising for the scientist. What was the reason? Of course we came to know what? Ethoxyethane in ಒಂದು boiling point to 307 Kelvin untu. Adre butane 1-ol in the boiling point was nearly 390 Kelvin. How much? 390 Kelvin. Of course, now a big question mark was existing in our mind. What was the reason for this? Of course, both are having the same molecular mass. Only difference is what? It is having ether as a functional group. It is having hydroxy as a functional group. Alva, OH as a functional group. Remember what our thinking was there. It is the same reason. That is, this functional group itself is mattering in a drastic change of your boiling point. How, sir? Remember, what is happening in alcohols? In alcohols, remember, very much important, there exists an intermolecular hydrogen bonding. What is existing? Intermolecular hydrogen bonding. ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಅಂದ್ರೆ ಅರ್ಥ ಏನು? ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಬ್ರೇಕ್ ಆಗಬೇಕು, ಅದು ವೇಪರ್ ಸ್ಟೇಟ್ ಗೆ ಹೋಗ್ಬೇಕು, ಕುದಿಬೇಕು ಅಂದ್ರೆ ಅರ್ಥ ಏನು? ಇಫ್ ಐ ಕನ್ಸಿಡರ್ ಎ ಮತ್ತೆ ಎ, ದಿಸ್ ಶುಡ್ ಬ್ರೇಕ್. ಈ ಬ್ರೇಕ್ ಆಗ್ಬೇಕು ಅಂದ್ರೆ ಅರ್ಥ ಏನು? ಏನೋ ಒಂದು ಅಮೌಂಟ್ ಆಫ್ ಎನರ್ಜಿ ಪಾಸ್ ಮಾಡಬೇಕು. ಅದೆಲ್ಲರೂ ಕಮ್ಮಿ ಎನರ್ಜಿ ಪಾಸ್ ಮಾಡ್ತಿದ್ರೆ ಅರ್ಥ ಏನು? ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಕಡಿಮೆ. ಎಲ್ಲರೂ ಎನರ್ಜಿ ಜಾಸ್ತಿ ಸಪ್ಲೈ ಮಾಡ್ತಿದ್ರೆ ಅರ್ಥ ಏನು? ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಜಾಸ್ತಿ. ಅದೇ ರೀತಿ ಆಲ್ಕೋಹಾಲ್ಸ್ ತಗೊಂಡಾಗ ಏನಂತಾರೆ ಅವರು? There is an intermolecular hydrogen bonding. What is there? Intermolecular. So ಏನಾಗುತ್ತೆ? Molecules are all associated. So ಅದನ್ನ ಬ್ರೇಕ್ ಮಾಡಕ್ಕೆ ನಾನು ಹೈ ಎನರ್ಜಿನ ಕೊಡಬೇಕು. ಆ ರೀಸನ್ ಇಂದಾನೆ ಆಲ್ಕೋಹಾಲ್ಸ್ ಅಲ್ಲಿ ಅತಿ ಹೆಚ್ಚು ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಕಾಣ್ತಾ ಉಂಟು when compared to its comparable molecular mass of its ether. Ethers ಅಲ್ಲಿ ಯಾಕೆ ಕಾಣ್ತಾ ಇಲ್ಲ ಅಂದ್ರೆ, because in ethers such intermolecular hydrogen bonding is not existing. Such intermolecular hydrogen bonding is not existing. So what is the first important thing that strikes to our mind over here? Yes. Compared to ethers and alcohols of a comparable molecular mass. I repeat, compared to ethers and alcohols of comparable molecular mass, remember, alcohols will be having the highest boiling point. The only reason is because in alcohols you can see an intermolecular hydrogen bonding. Is that clear? So this intermolecular hydrogen bonding ಆಗಿರಬಹುದು, intramolecular hydrogen bonding is very much important. That concept itself is ruling the boiling point and melting point of your or respective organic compounds. So if we observe a hydrogen bonding untu andre, of course there will be certain changes in the boiling point. So this is the one hint one has to know. So till now you just recall, now you just compare. Again, ಯಾವ ತರ ನಾವು ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಸ್ ಪ್ರಿಪೇರ್ ಆಗಬೇಕು ಇಲ್ಲಿವರೆಗೆ ಅಂದ್ರೆ, now you just take ಕಂಪೇರೇಬಲ್ ಮಾಲಿಕ್ಯುಲರ್ ಮಾಸಸ್ ಆಫ್ ಫಸ್ಟ್ ಆಲ್ಕೇನ್ಸ್ ನ ತಗೊಳ್ಳಿ, ಆಮೇಲೆ ಹ್ಯಾಲೋ ಆಲ್ಕೇನ್ಸ್ ನ ತಗೊಳ್ಳಿ, ಹ್ಯಾಲೋ ಅರೀನ್ಸ್ ನ ತಗೊಳ್ಳಿ, ಆಲ್ಕೋಹಾಲ್ ನ ತಗೊಳ್ಳಿ, ಫಿನಾಲ್ ನ ತಗೊಳ್ಳಿ, ಈಥರ್ ನ ತಗೊಳ್ಳಿ, ಕಂಪೇರೇಬಲ್ ಮಾಲಿಕ್ಯುಲರ್ ಮಾಸ್ ನ ತಗೊಳ್ಳಿ. ಈಗ ಅದನ್ನ ನೀವು ಇನ್ ದಿ ಇನ್ಕ್ರೀಸಿಂಗ್ ಆರ್ಡರ್ ಆಫ್ ಯುವರ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ನ ನೀವಾಗೆ ಒಂದು ಕ್ವಶನ್ ನ ಹಾಕೊಂಡು ಫ್ರೇಮ್ ಮಾಡಿ. So you'll get to know which will be having the highest boiling point. Then go with the reason. Why is it so? So there you will crack one important question. In case if they will give you a series of functional groups, ether ಕೊಟ್ಟು, alcohol ಕೊಟ್ಟು, phenols ಕೊಟ್ಟು, ನಿಮ್ಗೆ halo alkanes ಕೊಟ್ಟು, ಇದನ್ನ ಅರೇಂಜ್ ಮಾಡಿ ಅಂದಾಗ you can easily crack those questions. So that is the reason this physical properties understanding is very much important. Is that clear? Okay. So what we came to know with respect to the boiling point, compared to alkenes and ethers of comparable molecular mass, remember both will be having nearly same boiling point. But when you are comparing your ethers and alcohols of a comparable molecular mass, what will be having, which one will be having the highest? Yes, alcohols will be having the highest. The only reason is because due to its intermolecular hydrogen bonding. And do remember, again and again I am stressing the word as what? Comparable molecular mass. I am comparing the two different organic compounds which are having the equal or nearly equal comparable molecular masses. Is that clear? Okay, so this was the thing what we have come to know with respect to the boiling point. Now if I check about your solubility, remember, like our alcohols, ethers are also miscible in water. So alcohols, ಯಾವ ತರ ನಾವು ನೋಡಿದ್ವಲ್ಲ, lower membered alcohols, they were miscible in water. Here also what we are knowing, ethers are also miscible in water. The only reason for its miscibility is, yes, ethers are forming hydrogen bonds with water. Ethers are forming hydrogen bonds with water. And whatever this hydrogen bond is formed is by the oxygen of ether. Oxygen in ether in oxygen enuntalla, that is forming the hydrogen bonds with water, and that is the reason your ethers are soluble in water. For example, if I check out in this way, this is my ether, you can just see that it is forming in this way. This is HOH, this is your water. Okay, similarly here also HOH. So can you see? So like this, with respect to the oxygen, ether's oxygen is involved in the hydrogen bonding with water. Therefore, ethers are soluble in water like that of your alcohols. ಯಾವುದೇ ಒಂದು ಆರ್ಗ್ಯಾನಿಕ್ ಕಂಪೌಂಡ್ ವಾಟರ್ ಅಲ್ಲಿ ಸಾಲ್ಯುಬಲ್ ಆಗಬೇಕು ಅಂದ್ರೆ, I have mentioned so many times, again I am mentioning, what is the main thing should happen? They should form hydrogen bonds with water. But when we consider your alkanes of the comparable molecular mass, for example, if I choose your N-pentane ಇದೇ ಸೇಮ್ ಎಕ್ಸಾಂಪಲ್ ನ ತಗೊಂಡೋಣ. N-pentane, ethoxy ethane ಮತ್ತೆ ಬ್ಯೂಟೇನ್ ಒನಾಲ್ ನ ತಗೊಂಡಾಗ, of course your ethoxy ethane and butane ಒನಾಲ್, their solubility range is same. I will be mentioning how much it is. But when I am considering your ethoxy ethane and that of your N-pentane, of course N-pentane will be immiscible in water. When you're coming across with the two important new words, alva, miscible and immiscible. Immiscible means what? Miscible andre adu mix ಆಗ್ತಾ ಉಂಟು ಅಂತ. Okay, like for example, what you can say, salt water in normal water, ಎರಡು ಮಿಕ್ಸ್ ಆಗುತ್ತೆ. Immiscible ಅಂದ್ರೆ oil in water, ಎರಡು ಲೇಯರ್ ಸಪರೇಟ್ ಆಗುತ್ತೆ. That is called as immiscible. This is called as miscible, means completely mixing. This is not mixing. Immiscible means not mixing. Remember, whatever the alkenes we are having, they are immiscible in water. Immiscible in water. The only reason is what? Yes, alkanes ಹತ್ರ ಯಾವ ತರದ್ದು ಆ ತರ ಒಂದು ಆಟಮ್ಸ್ ಇಲ್ಲ, ಯಾವುದು ಹೈಡ್ರೋಜನ್ ಬಾಂಡ್ ವಾಟರ್ ಜೊತೆ ಮಾಡಬಹುದು. So since it lacks the formation of hydrogen bonding with water, your alkanes are immiscible in water. Is that clear? So two important physical properties we came to know today with respect to the ethers. What are those? Yes, when we are comparing the ethers of comparable molecular mass with alkanes and alcohols, we came to know that ethers are having the same boiling point as that of the alkenes. But when we compare your ethers and alcohols, of course your alcohols will be having the highest boiling point. The only reason is because in alcohols we can find an intermolecular hydrogen bonding, whereas in ethers such intermolecular hydrogen bonding is not existing. Coming with respect to the solubility of ethers, we came to know that of course like alcohols, your ethers are also soluble in water, because whatever in ethers the oxygen atom is there, they are involved in hydrogen bonding with water. Since once a hydrogen bonding is present in water with respect to the water, of course those organic compounds will be soluble in water. But alkanes ಅಲ್ಲಿ ಆ ತರ ಒಂದು ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್ ಆಬ್ಸೆಂಟ್ ಆಗ ಕಾರಣದಿಂದ ಏನಾಗುತ್ತೆ, alkanes are immiscible in water. So these are the two important physical properties we have dealt today with respect to that of your ethers. But I would like to continue this video with respect to one important reaction, okay, of your ethers. Basically physical properties na ನೋಡಾಯಿತು. ಈಗ ನಾವು chemical properties ನೋಡೋಣ. ಈ ವಿಡಿಯೋದಲ್ಲಿ just one chemical property na ನಾವು ನೋಡಕ್ಕೆ ಹೋಗ್ತಾ ಇದೀವಿ, that is the reactions involving the cleavage of CO bond. Cleavage of CO bond of ether. CO bond of ether. So this is coming under the topic of your chemical properties, where we are going to study the reactions where we will be seeing the breaking of CO bond in ether to form the final product. Is that clear? So guys, now let us look after the reactions involving the cleavage of CO bond of ether. So first important point one has to know under this reaction, what is that? To cleave CO bond in ethers, CO bond in ethers is difficult. Yes, difficult. And therefore, if you want to carry out these reactions, we are going to carry out them in drastic conditions. Drastic conditions. Is that clear? First important point one has to know whenever we are reading about those reactions, whether it is easy or whether it is difficult. One case if it is difficult, but also we have to do it, means what we have to do, we have to put some drastic condition. So in this video I'm just going to cover one of the most interesting and important reaction, okay, under the cleavage of your CO bond. That is what happens when ethers are treated with hydrogen halides. When ethers are treated with hydrogen halides. Remember, generally ethers reacts with the hydrogen halides to give alcohols or alkyl halides, and these products are depending upon the temperature. So a different temperature mardaga you will be getting a different types of a product. Why I am saying this? You'll come to know when I give certain examples. But one important thing what you have to know before looking for the reaction is that, of course, when ethers are treated with a hydrogen halide, you're going to get alcohols or an alkyl halides. But these products depends upon the temperature of the reactions. Okay. So now let's begin with what happens when ethers reacts with cold concentrated HI. Cold concentrated hydrogen iodide. Please mark the word over here as a cold. Okay. First let me give you the reaction. Why I am saying this, because remember, because what type of a product you are going to obtain here, the same product will not be obtained. I repeat, the same product will not be obtained when the same ether reacts with a hot concentrated HI. So you have to make a note of this. You'll come to know in a better way when I give certain examples. But do remember, now we'll talk about your ethers reacting with a cold concentrated HI. So remember, when ethers are treated with a HI, that is your hydrogen iodide, okay, we are going to get, of course, one will be our alcohol, and another product will be our respective alkyl iodide. What I am saying, when ethers are treated with a cold concentrated hydrogen iodide, one product we are going to get as an alcohol and another is that of your alkyl iodide. Is that clear? Now let's have certain examples. That is, first let me take as symmetrical ethers. What I am saying, first let I take the example of an ether as a symmetrical ethers. Okay. So basically, if I choose here as a methoxymethane, CH3O, CH3. When I am treating this one with a concentrated HI which is maintained at the cold condition, what I am getting? CH3OH plus CH3I. Of course, here there is no problem. But now if I choose unsymmetrical ethers, unsymmetrical ethers, very much important in competitive exam point of view. Okay, why? I will just say in a fraction of time. If I take as an ethoxyethane, C2H5O, CH3, what I have to, methoxyethane I have chosen, plus HI in the cold condition. What is the product you are going to get will be astonishing. C2H5OH plus CH3I. You can ask me, so what is much astonishing over here? Of course, we have got an alcohol, but an alkyl iodide. Astonishing is what I will just say now. Remember, this is the product you are going to get, but we will not get CH3OH plus C2H5I. That is what I wanted to say over here is, whatever the product we are going to get when methoxyethane is treated with a cold hydrogen iodide is an ethanol plus methyl iodide. Are you getting my point? But we will not get methanol and ethyl iodide. The question arises, why? Alva? Of course, I ಹೇಳಿದೆ ಒಂದು alcohol ಕೊಡಬೇಕು ಒಂದು iodide ಕೊಡಬೇಕು. ಆದರೆ ನಾನು ಸ್ಪೆಸಿಫಿಕ್ ಆಗಿ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, when I am talking about unsymmetrical ethers, you will get this alcohol itself, this iodide itself, but vice versa. That is, the ulta thing is not possible. Question arises, why? Remember, I'll just give you one important hint over here. What is the hint, sir? So whenever we talk about unsymmetrical ethers which are treated with a cold concentrated HI, remember, your iodide ion attacks the smaller alkyl group. The smaller alkyl group. What is that? In which one? When we treat in unsymmetrical ethers. In unsymmetrical ethers. Symmetrical problem ಇಲ್ಲ, ಯಾಕಂದ್ರೆ ಎರಡು ಕಡೆನೂ ಒಂದೇ ರೀತಿ ಆಲ್ಕಿಲ್ ಗ್ರೂಪ್ ಇರುತ್ತೆ, ಯಾವ ತರ ಪ್ರಾಡಕ್ಟ್ ಬಂದ್ರೆ ಚೇಂಜ್ ಆಗೋದಿಲ್ಲ. ಆದ್ರೆ unsymmetrical ethers ಅಲ್ಲಿ you should keep in your mind, what is that? Whatever the iodide ion which is going to generate from HI, it is going to attack our smaller alkyl group. That is the reason. ಇಲ್ಲಿ iodide ಇವೆರಡನ್ನ ಕಂಪೇರ್ ಮಾಡಿದಾಗ ಯಾವುದು ಸ್ಮಾಲರ್ alkyl group? Of course, our methane group. So iodide comes and attacks this methyl group, leading to the formation of methyl iodide. ಉಳಿದಿದ್ದ ಭಾಗದಲ್ಲಿ EH ಅಟ್ಯಾಚ್ ಆಗಿ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಎಥೆನಾಲ್ ಅಥವಾ ಆಲ್ಕೋಹಾಲ್ ನ ಕೊಡುತ್ತೆ. ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್ ಗೊತ್ತಾಯ್ತಾ? Symmetrical ethers ಅಲ್ಲಿ ಏನ್ ಗೊತ್ತಾಯ್ತು? ಫಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್ ಅಂದ್ರೆ, when you treat ethers with a cold concentrated HI, one is an alcohol, another is an alkyl iodide ಸಿಗುತ್ತೆ. ಸೆಕೆಂಡ್ ಏನ್ ಬಂತು, when you are treating your unsymmetrical ethers, ಒಂದು ಪ್ರಾಡಕ್ಟ್ ನಿಮಗೆ ಆಲ್ಕೋಹಾಲ್, ಇನ್ನೊಂದು ಆಲ್ಕಿಲ್ ಐಡೈಡ್ ಸಿಗುತ್ತೆ. ಆದ್ರೆ ಆ ಆಲ್ಕಿಲ್ ಐಯೋಡೈಡ್ ಏನುಂಟಲ್ಲ, that iodide part is going to attack the smaller alkyl group. It doesn't stop over here, guys. Once again I talk about now is unsymmetrical ethers. Notice whether this is same applicable for tertiary alkyl group idru agutta ನನ್ನ ಕನ್ಫ್ಯೂಷನ್ ಆಯ್ತು. ಏನು ಅಂದ್ರೆ, for example, if I am having CCH3 CH3 CH3 OCH3, this is your tertiary alkyl ether untu na tagonana alva. Tertiary alkyl ether, it is we are having a tertiary alkyl group is present. So when I treated this one with a HI in the cold condition, what should be my product according to the unsymmetrical ethers? Of course, this I should get bonded with that of your CH3. But here once again it was a quite surprise for us, because here what the product you got was something vice versa. That is, the iodide ion is attacking the tertiary alkyl group and you are going to get as a methanol, CH3OH. ಹಾಗಾದ್ರೆ ಅರ್ಥ ಏನು? When you're talking about an unsymmetrical ethers, the bond was broken between here. ಅಲ್ವಾ? ಅವಾಗ ಮಾತ್ರ ತಾನೆ CH3 ಪ್ಲಸ್ ಆಗಿ ಹೊರಗೆ ಬರಕ್ಕೆ ಸಾಧ್ಯ. But when you're talking about a tertiary alkyl ethers, the bond is breaking over here. Okay, so you're seeing these are things. What are the proofs and evidence? How can we remember this? Another concept bandre. You can be better understanding if I give its mechanism. Don't worry, I'm not going to give a complex mechanism. Just the simple words I'm going to say, which we have dealt earlier. What is that? Simple thing. When you're treating your unsymmetrical ethers with a cold hydrogen iodide, remember, it is undergoing SN2 mechanism. What it is undergoing? SN2 mechanism. But when you're treating a tertiary alkyl ether with a cold HI, remember, it is undergoing SN1 mechanism. SN1 mechanism. What is the thing differences, sir? Of course, ನಮ್ಗೆ ಏನ್ ಗೊತ್ತು, SN2 ಅಲ್ಲಿ you just recall, SN2 ಅಲ್ಲಿ ಇನ್ಕಮಿಂಗ್ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಯಾವ ಕಡೆಯಿಂದ ಅಟ್ಯಾಕ್ ಆಗುತ್ತೆ? ಆಪೋಸಿಟ್ ಕಡೆಯಿಂದ ಅಟ್ಯಾಕ್ ಆಗುತ್ತೆ. ಯಾಕೆ ಆಗ್ತಾ ಉಂಟು? ಇನ್ ಆರ್ಡರ್ ಟು ಅವಾಯ್ಡ್ ಸ್ಟಿರಿಕಲ್ ಹಿಂಡ್ರನ್ಸ್ ಅಲ್ವಾ? ಐ ಆಮ್ ರಿಪೀಟಿಂಗ್ ಒನ್ಸ್ ಅಗೇನ್. ಯು ಜಸ್ಟ್ ರಿವೈಂಡ್ ದಿ ಪೇಜಸ್ ಇನ್ ಯೋರ್ ಮೈಂಡ್. Go to your haloalkenes and haloarenes chapter. See, focus over there about SN2 mechanism. When your methyl bromide is treated with an aqueous KOH, ಯಾವ ತರ ಅಲ್ಲಿ ಬರ್ದಿದೀವಿ ನಾವು ಸ್ಟ್ರಕ್ಚರ್ಸ್? ಮಿಥೈಲ್ ಬ್ರೋಮೈಡ್ ಸಿ ಮಧ್ಯದಲ್ಲಿ ಬರ್ದಿ 3H ಬರ್ದಿದೀವಿ. ಒಂದ್ ಕಡೆ ನಿಮ್ಮ Br ಉಂಟು, ಹಿಂಗಡೆಯಿಂದ ನಾವೇನ್ ಮಾಡಿದೀವಿ? OH ಮೈನಸ್ ನ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡಿದೀವಿ. ದಟ್ ಇಸ್ ಬ್ರೋಮೈಡ್ ಇನ ಆಪೋಸಿಟ್ ಸೈಡ್ ಇಂದ OH ಮೈನಸ್ ಅಟ್ಯಾಕ್ ಆಗ್ತಾ ಉಂಟು. ಯಾಕೆ? ಇನ್ ಆರ್ಡರ್ ಟು ಅವಾಯ್ಡ್ ದ ಸ್ಟಿರಿಕಲ್ ಹಿಂಡ್ರನ್ಸ್. ಹಾಗಾದ್ರೆ ಅರ್ಥ ಏನಾಗ್ತಾ ಉಂಟು? SN2 ಆಗ್ತಾ ಉಂಟು ಅರ್ಥ ಏನು? ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ವಿಲ್ ಆಲ್ವೇಸ್ ಟ್ರೈ ಟು ಅಟ್ಯಾಕ್ ಫ್ರಮ್ ಬ್ಯಾಕ್ ಸೈಡ್. ಯಾಕೆ? ಇನ್ ಆರ್ಡರ್ ಟು ಅವಾಯ್ಡ್ ಸ್ಟಿರಿಕಲ್ ಹಿಂಡ್ರನ್ಸ್. ಅಫ್ ಕೋರ್ಸ್ ವೆನ್ ಯು ಟ್ರೀಟ್ ಅಬೌಟ್ ಯು ಅನ್ಸಿಮೆಟ್ರಿಕಲ್ ಈಥರ್ಸ್, I ಮೈನಸ್ ಜನರೇಟ್ ಆಗ್ತಾ ಉಂಟು. ಹಾಗಾದ್ರೆ I ಮೈನಸ್ ವಿಲ್ ಬಿ ಆಕ್ಟಿಂಗ್ ಆಸ್ ವಾಟ್? ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್. ಈಗ ಇದನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡೋಣ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, C2H5O ಉಂಟಪ್ಪ. ಈಗ ಇಲ್ಲಿಗೆ ಬಂದು ಅಟ್ಯಾಚ್ ಆಗ್ಬೇಕು. ಅರ್ಥ ಏನಾಗುತ್ತೆ? ದಿಸ್ ಇಸ್ ನೌ ಸಮ್ ವಾಟ್ ಸ್ಟಿರಿಕಲಿ ಹಿಂಡರ್ಡ್. ಯಾಕೆ? ಬಲ್ಕಿ ಗ್ರೂಪ್ ಉಂಟು. ಸೊ I ಮೈನಸ್ ಏನ್ ಮಾಡುತ್ತೆ? ಈಸಿಯಾಗಿ ಅಪ್ರೋಚ್ ಮಾಡೋದು ಕಷ್ಟ. ಸೊ ಅದೇನ್ ಮಾಡುದು? ಆಲ್ಟರ್ನೇಟ್ ಮೆಥಡ್ ನೋಡ್ಕೊಳುತ್ತೆ. ಯಾವ್ದದು? CH3 ಪ್ಲಸ್ ಕಡೆಗೆ ಹೋಗುತ್ತೆ. ಅಫ್ಕೋರ್ಸ್ ನನಗೆ CH3 ಮಿಥೈಲ್ ಗ್ರೂಪ್ 3 ಹೈಡ್ರೋಜನ್, ಯಾವ ತರದ್ದು ಬಲ್ಕಿ ಗ್ರೂಪ್ ಇಲ್ಲ. ಸೊ I ಮೈನಸ್ ಏನಾಗುತ್ತೆ? ಡೈರೆಕ್ಟ್ ಆಗಿ ಹೋಗಿ ಅಟ್ಯಾಚ್ ಆಗ್ಬಿಡುತ್ತೆ. ಸೊ ಯಾವ ರಿಯಾಕ್ಷನ್ ತುಂಬಾನೇ ಬೇಗ ಆಗಕ್ ಸಾಧ್ಯ, ತುಂಬಾನೇ ಕಷ್ಟ ಇರೋದಿಲ್ಲ, ಆ ಪಾತ್ನ ಆ ನ್ಯೂಕ್ಲಿಯೋಫೈಲು ಯಾವತ್ತೇ ಆಗ್ಲಿ ಇಷ್ಟಪಡುತ್ತೆ. ಸೊ ದಟ್ ಈಸ್ ದ ರೀಸನ್ ಯುವರ್ ಅನ್ಸಿಮೆಟ್ರಿಕಲ್ ಈಥರ್ಸ್ ಟ್ರೀಟ್ ಆದಾಗ ಯುವರ್ ಅಯೋಡೈಡ್ ಇಸ್ ಗೋಯಿಂಗ್ ಅಂಡ್ ಅಟ್ಯಾಚಿಂಗ್ ಟು ದಟ್ ಆಫ್ ಯುವರ್ ಮಿಥೈಲ್ ಗ್ರೂಪ್ ಬಿಕಾಸ್ ಆಫ್ ಇಟ್ ಇಸ್ ಫಾಲೋಯಿಂಗ್ ವಾಟ್? SN2 mechanism. ಆಯ್ತಾ? ಬಟ್ ವೆನ್ ಯು ಆರ್ ಟಾಕಿಂಗ್ ಅಬೌಟ್ ಯುವರ್ ಟರ್ಷರಿ ಆಲ್ಕಿಲ್ ಈಥರ್, ವಾಟ್ ಇಸ್ ದ ರೀಸನ್? ಇಟ್ ಈಸ್ ಅಂಡರ್ಗೋಯಿಂಗ್ SN1. SN1 ಅಲ್ಲಿ ಸ್ಲೋ ಸ್ಟೆಪ್ ಯಾವುದು? ಫಾರ್ಮೇಶನ್ ಆಫ್ ಅ ಕಾರ್ಬೋಕ್ಯಾಟಯೋನ್. ಸೊ ಇಲ್ಲೇನಾಗುತ್ತೆ? ಈಗ ಇಲ್ಲಿ ಬ್ರೇಕ್ ಆದ್ರೆ ಟರ್ಷರಿ ಕಾರ್ಬೋಕ್ಯಾಟಯೋನ್ ಸಿಗುತ್ತಾ? ಇಲ್ಲಿ ಬ್ರೇಕ್ ಆದ್ರೆ ಪ್ರೈಮರಿ ಕಾರ್ಬೋಕ್ಯಾಟಯೋನ್. ಯಾವ್ದು ಕಂಪೇರೇಬಲ್ ಜಾಸ್ತಿ ನಮ್ಗೆ ಸ್ಟೆಬಿಲಿಟಿ? ಅಫ್ಕೋರ್ಸ್ ಟರ್ಷರಿ. ಸೊ ಏನಾಗುತ್ತೆ? ರಿಯಾಕ್ಷನ್ ಈಗ ಸ್ಟೇಬಲ್ ಕಡೆಗೆ ಹೋಗಕ್ಕೆ ಇಷ್ಟಪಡುತ್ತೆ. ಸೊ ಟರ್ಷರಿ ಕಾರ್ಬೋಕ್ಯಾಟಯೋನ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ, ಅದು ಸ್ಟೇಬಲ್. I ಮೈನಸ್ ಏನ್ ಮಾಡುತ್ತೆ? ಓಕೆ, ಇದು ಸ್ಟೇಬಲ್ ಉಂಟು, ಇದತ್ರ ನಾ ಬೇಗ ಹೋಗ್ಬಿಟ್ರೆ ನಾನು ಸ್ಟೇಬಲ್ ಆಗ್ತೀನಿ ಅಂತ ಹೇಳ್ಕೊಂಡು ಏನ್ ಮಾಡುತ್ತೆ? ದಟ್ ವಿಲ್ ಗೋ ಅಂಡ್ ಅಟ್ಯಾಕ್ ಅವರ್ ಟರ್ಷರಿ ಆಲ್ಕಿಲ್ ಗ್ರೂಪ್. Are you getting my point? So when your unsymmetrical ethers are treated with a hydrogen iodide, your iodide group attacks the smaller alkyl group. What is the reason? Because it undergoes an SN2 mechanism. But when we talk about your tertiary alkyl ethers, remember, your iodide ion attacks to the tertiary alkyl group because it follows which one? SN1 mechanism. Of course, these are not important for your PU board exam. Again and again I am repeating, they are important for your competitive exams. So these are the key points. ಅರ್ಥ ಮಾಡ್ಕೊಳಕ್ಕೆ ಸ್ವಲ್ಪ ನೀವು ಟ್ರೈ ಮಾಡ್ಕೋಬೇಕು. ಏನಾಗ್ತಾ ಉಂಟು ಅನ್ಸಿಮೆಟ್ರಿಕಲ್ ಈಥರ್ಸ್ ಅಲ್ಲಿ ನಾನು ತೋರಿಸಿದೆ. ಈಗ ಇಲ್ಲೇ ತಗೊಳ್ಳೋಣ, ಇನ್ನೊಂದ್ಸರಿ ತೋರಿಸ್ತೀನಿ. C2H5O CH3 ಉಂಟು. ಅಫ್ಕೋರ್ಸ್ ನಂಗೆ ಏನ್ ಗೊತ್ತು SN2 ಮೆಕ್ಯಾನಿಸಮ್ ಅಲ್ಲಿ ಯಾವ ತರದ್ದು ಕಾರ್ಬೋಕ್ಯಾಟಯನ್ ಬರೋದಿಲ್ಲ. ಸೊ ಈಗ ಏನ್ ಮಾಡ್ಬೇಕು, ಇದ್ರಲ್ಲಿ ಈಗ ಏನಾದ್ರೂ ಒಂದು ಅದು ಜೋಲ್ನ ಮಾಡ್ಕೋಬೇಕು. ಸೊ ಐ ಈಗ ಏನ್ ಮಾಡುತ್ತೆ, ಫಸ್ಟ್ ಇದ್ರ ಹತ್ರ ಬರೋಕೆ ಟ್ರೈ ಮಾಡಿದ್ದು I-, ರಿಮೆಂಬರ್. ಈಗ ಇದು ಕೂಡ ಏನಾಗಿರುತ್ತೆ, ಬಲ್ಕಿ ಗ್ರೂಪ್ಸ್. ನಮ್ಗೆ ಗೊತ್ತು ಆಲ್ಕಿಲ್ ಆರ್ ಆಲ್ಸೋ ಎಲೆಕ್ಟ್ರಾನ್ ಡೊನೇಟಿಂಗ್ ಗ್ರೂಪ್. ಸೊ ಇದ್ರ ಹತ್ರ ಕೂಡ ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ ಜಾಸ್ತಿ ಉಂಟು. ಎಷ್ಟುಂಟು ಇದರಲ್ಲಿ 2 ಪಟ್ಟು ಉಂಟು. ಇದು ಏನೋ 1 ಪಟ್ಟು ಇದ್ರೆ ಇದು 2 ಪಟ್ಟು ಉಂಟು. ಆದ್ರೆ ಇದ್ರ ಹತ್ರ ಏನುಂಟು, ಒಂದೇ ಆಲ್ಕಿಲ್ ಗ್ರೂಪ್, 1:1 ರೇಷಿಯೋ, 1 ಪಟ್ಟು 1 ಉಂಟು. ಸೊ ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಗೋಯಿಂಗ್ and struggling, what it will try to do, it will easily choose a way where it has no struggle at all. So our reason in the unsymmetrical ethers alli, remember, iodide ion attacks to your smaller alkyl group. Of course, now this is also an unsymmetrical ether, but in unsymmetrical ether, if you are having a tertiary alkyl group, what happens, your iodide ion attacks to that tertiary alkyl group because it is undergoing SN1. SN1 ಅಂದ್ರೆ ಅರ್ಥ ಏನು? Of course, the slowest step includes formation of a carbocation. So, ಈ carbocation highly stable ಅಲ್ವಾ? Tertiary carbocation is more stable when compared to primary carbocation. So, ಈಸಿಯಾಗಿ ಏನಾಗುತ್ತೆ, ಈ ಬಾಂಡ್ ಈಗ ಬ್ರೇಕ್ ಆಗ್ಬಿಡುತ್ತೆ. ಅವಾಗ ಏನಾಯ್ತು, ಇಲ್ಲಿ ಪ್ಲಸ್ ಬರುತ್ತೆ, ಟರ್ಷರಿ ಕಾರ್ಬೋಕ್ಯಾಟನ್ ಆಯ್ತು. I- ಹೊರಗೊಂಡು ಅದು ಪ್ಲಸ್ ಕಡೆಗೆ ಬಂದ್ಬಿಡುತ್ತೆ. ಉಳಿದಿದ್ದೇನೀಗ CH3O-. ಸೊ ಆ CH3O- ಹತ್ರ ಈ H+ ಬಂದು ನಿಮ್ಗೆ methanol ಕೊಡುತ್ತೆ. You just remember what, whenever you are treating your ethers with a cold concentrated HI, one product you are going to get an alcohol, another you are going to get an alkyl iodide. This is first note you have to remember. Second note, whenever you treat your unsymmetrical ethers with a cold concentrated HI, the iodide ion attacks the alkyl group which is smaller, or your iodide ion attacks the smaller alkyl group. In the same unsymmetrical ethers, if you are having a tertiary alkyl group, remember, your iodide ion attacks the tertiary carbocation or a tertiary alkyl group. These are the important things you have to make a key point in ethers. Don't feel in a hectic. Yavadana both complete we have to study. Okay, then only you'll be giving a clear picture of the overall concept. ಯಾವ ತರ ಕ್ವಶನ್ ಟ್ವಿಸ್ಟ್ ಮಾಡಿದ್ರು ಕೂಡ it will be easy for you to answer them. Is that clear? Of course. Now let me go back to my page. So what did I say? Of course, when ethers are reacting with the hydrogen iodides, you're going to give us an alcohols and alkyl iodides. But remember, the product depends upon the temperature of the reaction. Why did I say so? The main reason is, when the same ethers are treated with hot concentrated HI. Enidu hot concentrated HI. Remember, you are going to get the product as both alkyl iodide itself. Both as an alkyl iodide. That means what? For example, if I choose C2H5OCH3, when it is treated with your HI in the hot condition, remember hot condition, we are going to get as what? C2H5I plus CH3I. ಕೋಲ್ಡ್ ಕಂಡೀಷನ್ ಅಲ್ಲಿ ಒಂದು ಆಲ್ಕೋಹಾಲ್ ಮತ್ತೆ ಆಲ್ಕಿಲ್ ಐಡೈಡ್ ಸಿಕ್ಕಿದ್ರೆ, ಹಾಟ್ ಕಂಡೀಷನ್ ಅಲ್ಲಿ ನಮಗೆ 2 ಆಲ್ಕಿಲ್ ಐಡೈಡ್ ಸಿಗ್ತಾ ಉಂಟು. ವೈ ಐ ಆಮ್ ಸೇಯಿಂಗ್ ದಿಸ್, ಇನ್ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಸ್ ದೇರ್ ಮೇ ಬಿ ಅ ಚಾನ್ಸ್ ದೇ ಕ್ಯಾನ್ ಆಸ್ಕ್ ಯು ದಿಸ್. ಈ ತರ ಆರೋ ಮಾರ್ಕ್ ಕೊಟ್ಟಿ ಹಾಟ್ ಅಂತ ಬಂದಿದೆ, ದೇ ಕ್ಯಾನ್ ಗಿವ್ ಯು ಸೀರೀಸ್ ಆಫ್ ಕ್ವಶನ್ಸ್ ಆರ್ ಆಪ್ಷನ್ಸ್. ಸೊ ರಿಮೆಂಬರ್, ಯು ಜಸ್ಟ್ ಸಿ ದಿ ಟೆಂಪರೇಚರ್ ಆಫ್ ದಿ ರಿಯಾಕ್ಷನ್. Whenever a ether is treated with a hot concentrated your hydrogen iodide adre, both the products will be your alkyl iodide itself. But in case if it will be cold condition, one will be an alcohol, another will be an alkyl iodide. Once again you have to make your mind shift. What is that? Nodi, unsymmetrical ethers, the iodide will attach to smaller alkyl group. Tertiary alkyl group, the iodide attacks to that tertiary alkyl group. Is that clear? Of course, the question arises over here. So, why is this so? Remember, I don't want to confuse you. I'm not going to give the mechanism. It is somewhat bulky mechanism. But I will just make you one thing ensure. What is that? Of course, in this also, ಯಾವುದೋ ಒಂದು mechanism step ಅಲ್ಲಿ alcohol introduce ಆಗುತ್ತೆ. Alcohol form ಆಗುತ್ತೆ. But it will not stay there. ಏನಾಗುತ್ತೆ ಅಲ್ಲಿ ವಾಪಸ್ ಅಂದ್ರೆ, that alcohol ಗೆ ವಾಪಸ್ ನಿಮ್ಮ I- ಬಂದು ಅಟ್ಯಾಚ್ ಆಗಿ ನಮಗೆ ವಾಪಸ್ ಆ ಆಲ್ಕೋಹಾಲ್ ಕೂಡ ಆಲ್ಕಿಲ್ ಐಡೈಡ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗ್ಬಿಡುತ್ತೆ. ಆ ರೀಸನ್ ಇಂದನೇ ನಮ್ಗಿಲ್ಲಿ ಯಾವ ತರದ್ದು ಆಲ್ಕೋಹಾಲ್ ಸಿಗೋದಿಲ್ಲ. ಇಸ್ ದಟ್ ಕ್ಲಿಯರ್? ದಟ್ ಇಸ್ ದ ರೀಸನ್ ವೆನೆವರ್ ವಿ ಆರ್ ಟ್ರೀಟಿಂಗ್ your ethers with your hydrogen iodide in the hot condition, both the products will be your respective alkyl iodide. Is that clear? No doubt? Okay. Important note. Let me give this part. ಈ ಪಾರ್ಟ್ನ ಹೇಳೋಯ್ತಪ್ಪ, ಈ ಪಾರ್ಟ್ನ ಇನ್ನೊಂದ್ಸರಿ ಒಂದು ಕರೆಕ್ಟ್ ಆಗಿ ಒಂದು ನಿಮ್ಗೆ ಅರ್ಥ ಮಾಡಿಸ್ತೀನಿ. So that is why it is forming in that way. CCH3, CH3, CH3. ಇಲ್ಲಿ ನಿಮ್ಗೆ OCH3 ಉಂಟಲ್ವಾ? ಓಕೆ, ಫಸ್ಟ್ ಏನಾಗುತ್ತೆ ನೋಡೋಣ. HI. Okay, I'm talking about in cold condition what is happening. Okay, just showing you the reaction path. ಯಾಕಂದ್ರೆ if you are knowing the mechanism, it will be easy for understanding. I'm not giving this one mechanism because it is somewhat bulk. I don't want to confuse you. Many steps are there. But do just remember what happens in the hot and what happens in the cold. Since this is simple, ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನಾವು ನೋಡಿದ್ವಿ ಅನ್ಸಿಮೆಟ್ರಿಕಲ್ ಒಂದ್ ಕಡೆ ಈ ತರ ಆದ್ರೆ ಇನ್ನೊಂದ್ ಕಡೆ ಯಾಕೆ ಈ ತರ ಅನ್ನೋದು some fellows will come to know when I'm saying SN2 and SN1, but some fellows will not come to know. For that reason, for them I'm giving. So first what happens, whatever the lone pair of electrons and oxygen is there, that is first going to attract your H part. So what you'll be getting here, CH3, 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 you will be getting as an OCH3. ಇಲ್ಲೇನಾಗಿದ್ದೀಗ OH ಬಂದಿದೆ, ಇಲ್ಲೇನಾಯಿತು ಪ್ಲಸ್ ಆಯಿತು. ಗೆಟಿಂಗ್ ಮೈ ಪಾಯಿಂಟ್? ಪ್ಲಸ್ ಈಗ ಏನು ಉಳ್ಕೊಂಡಿದೆ, I ಮೈನಸ್ ಉಳ್ಕೊಂಡಿದೆ. ಅಫ್ಕೋರ್ಸ್ ಈಗ ನೀವು ನೋಡಿ ಇಲ್ಲಿ ಎರಡು ಪಾರ್ಟ್ ಉಂಟು. ಏನು ಇಲ್ಲ, ಈ ಬಾಂಡ್ ಬ್ರೇಕ್ ಆಗಬೇಕಂದ್ರೆ ಆಕ್ಸಿಜನ್ ಮೇಲೆ ಪಾಸಿಟಿವ್ ಉಂಟು, ಯಾವುದೋ ಒಂದು ಬಾಂಡ್ ನ ಹೇಳ್ಕೊಳಕ್ಕೆ ಇಷ್ಟಪಡುತ್ತೆ. ಇಲ್ಲ ಈ ಬಾಂಡ್ ನ ಹೇಳ್ಕೊಂಡು CH3 ಪ್ಲಸ್ ಮಾಡಕ್ ನೋಡುತ್ತೆ. ಇಲ್ಲ ಈ ಬಾಂಡ್ ನ ಬ್ರೇಕ್ ಮಾಡ್ಕೊಂಡು C ಪ್ಲಸ್ ಮಾಡಕ್ಕೆ ಟ್ರೈ ಮಾಡುತ್ತೆ. ಅಂದ್ರೆ ಟರ್ಷರಿ ಕಾರ್ಬೋಕ್ಯಾಟನ್ ಆಗೋ ಚಾನ್ಸ್ ಉಂಟು, ಇಲ್ಲ ಪ್ರೈಮರಿ ಕಾರ್ಬೋಕ್ಯಾಟನ್ ಆಗೋ ಚಾನ್ಸ್ ಉಂಟು. ಈ ಮಾಲಿಕ್ಯೂಲಿಗೆ ಗೊತ್ತು ಏನಂತ, ನಾನು ಟರ್ಷರಿ ಕಾರ್ಬೋಕ್ಯಾಟನ್ ಆದ್ರೆ ಈ ಬಾಂಡ್ ಮುರಿದ್ರೂ ಕೂಡ ಅಲ್ವಾ, ಯಾಕಂದ್ರೆ ಬಾಂಡ್ ಇದ್ರೆ ಸ್ಟೇಬಲ್ ಅಂತ ಗೊತ್ತು ನಮ್ಗೆ ಅಲ್ವಾ. ಈ ಮಾಲಿಕ್ಯೂಲಿಗೆ ಏನ್ ಗೊತ್ತು, ಈ ಬಾಂಡ್ ಎಲ್ಲಾದ್ರೂ ಮುರಿದ್ರೂ ಕೂಡ ನಾನು ಸ್ಟೇಬಲ್ ಆಗೇ ಇರ್ತೀನಿ. ಯಾಕೆ? ಬಿಕಾಸ್ ಐ ವಿಲ್ ಬಿ ಅಂಡರ್ ಗೋಯಿಂಗ್ ವಾಟ್, I will be forming tertiary carbocation. So this molecule will say to the overall molecule, what is that? To the oxygen it will say, hey guy, don't break this bond. ಈ ಬಾಂಡ್ ನ ಬ್ರೇಕ್ ಮಾಡಬೇಡ ನೀನು. ಯಾಕೆ? ಈ ಬಾಂಡ್ ನ ಬ್ರೇಕ್ ಮಾಡಿದ್ರೆ ಅಫ್ಕೋರ್ಸ್ ನೀನು ಸ್ಟೇಬಲ್ ಅಲ್ಲ, ನನ್ನೂ ಸ್ಟೇಬಲ್ ಆಗಕ್ ಬಿಡೋದಿಲ್ಲ. ಸೊ ನೀ ಏನ್ ಮಾಡು, ನನ್ನ ಹತ್ರ ನೀನು ಬ್ರೇಕ್ ಮಾಡ್ಕೊ. ಸೊ ಇಟ್ ವಿಲ್ ಟ್ರೈ ಟು ಬ್ರೇಕ್ ನೌ ದಿಸ್ ಬಾಂಡ್. ಆರ್ ಯು ಏಬಲ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್? Now this molecule, whatever the tertiary alkyl group is there, it is saying to oxygen, what is it saying? Don't break this bond. Because if you break this bond, of course you will get the electron. That is a different matter. But the overall molecule will not be stable. So what you do, you also become stable by accepting the electron, and let me also be stable by forming a tertiary carbocation. So what it will try to do, it will try to take this bond towards itself. So what will happen? You will get over here as CH3, CH3, CH3 plus what is remaining now? CH3OH. Are you getting my point? Now whatever your I minus is there, that is going to go towards your plus. So overall you'll be getting as what now? Tertiary alkyl iodide. So ಈ ಒಂದು reason ಆಗ್ತಾ ಇರುತ್ತೆ. Since the step involves the formation of a carbocation, the slowest step, we are saying that it is following SN1 mechanism. Is that clear now? I hope there is no doubt. Okay. Now one more exception let us take. Okay sir, till now you have given us an aliphatic system. ಒಂದು ಅರಿನ್ ನ ತಗೊಂಡು ನಮಗೆ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿ ಅಂತ ಕೇಳಿದ್ರೆ, let me choose unsymmetrical ether ಅಲ್ಲಿ anisole ನ ತಗೊಂತೀನಿ. ಏನಿದು? anisole or methoxybenzene. Methoxybenzene is IUPAC name, but anisole is one of the most commonly used name. Anisole. Okay, C6H5OCH3. Now the question arises, what happens when I treat hydrogen iodide over here? Of course, ಏನು ಗೊತ್ತಾಯ್ತು, unsymmetrical ether ಇದ್ರೆ aliphatic system ಇದ್ರೆ ಗೊತ್ತಿತ್ತು, I minus will attack your smaller alkyl group. ಇನ್ನೊಂದು ಏನು ಗೊತ್ತಾಯ್ತು, ಅದೇ unsymmetrical ether ಅಲ್ಲಿ ನನಗೆ tertiary alkyl group ಇದ್ರೆ I minus will attack that tertiary alkyl. But here somewhat different condition. What is the different condition? Here we are having the benzene ring. Here what we are having? Benzene ring. But one important note we have come to know. One hint is there. What is that? Of course, if this I minus should go and attack, means what should happen? Either this bond should break. ಯಾಕಂದ್ರೆ ನಮ್ಗೆ ಗೊತ್ತು, ಒಂದು ಆಲ್ಕೋಹಾಲ್ ಬರಬೇಕು, ಒಂದು ಆಲ್ಕಿಲ್ ಐಡೈಡ್ ಬರಬೇಕು. ಹಾಗಾದ್ರೆ ಯಾವ್ದ ಹತ್ರ ಒಂದ್ ಹತ್ರನಾದ್ರೂ ಆಕ್ಸಿಜನ್ ಇರಲೇಬೇಕು. ಸೊ ಅದೇನು, ಇಲ್ಲ ಇದು ಆಕ್ಸಿಜನ್ ಇಟ್ಕೋಬೇಕು, ಇಲ್ಲ ಇದನ್ನ ಆಕ್ಸಿಜನ್ ಇಟ್ಕೋಬೇಕು. ಎಲ್ಲಾದ್ರೂ ಇದು ಆಕ್ಸಿಜನ್ ಇಟ್ಕೋಬೇಕು ಅಂದ್ರೆ ಈ ಬಾಂಡ್ ಬ್ರೇಕ್ ಆಗ್ಬೇಕು. ಎಲ್ಲಾದ್ರೂ ಇದು ಆಕ್ಸಿಜನ್ ಇಟ್ಕೋಬೇಕಂದ್ರೆ ಮಿಥೈಲ್ ಗ್ರೂಪ್ ಜೊತೆ ಆಕ್ಸಿಜನ್ ಇರಬೇಕು ಅಂದ್ರೆ ಈ ಬಾಂಡ್ ಬ್ರೇಕ್ ಆಗ್ಬೇಕು. ನಾವು ವಿಲ್ ಬಿ ಥಿಂಕಿಂಗ್ ಯಾವ ಬಾಂಡ್ ಬೇಗನೆ ಬ್ರೇಕ್ ಆಗೋ ಸಾಧ್ಯತೆ ಉಂಟು. ನಾವು ಸಿ ಗೈಸ್, ರಿಮೆಂಬರ್ ದ ಬಾಂಡ್ ಬಿಟ್ವೀನ್ ದಿ ಸಿ ಅಂಡ್ ಓ ಇನ್ ಯೋರ್ ಬೆನ್ಝೀನ್ ರಿಂಗ್, ಈ ಬಾಂಡ್ ನ ಬ್ರೇಕ್ ಮಾಡೋದು ಸ್ವಲ್ಪ ಕಷ್ಟ. ಇಟ್ ಇಸ್ ಸಮ್ ವಾಟ್ ಹಾರ್ಡ್. Why? Because whatever the carbon over here is there, that is sp2 hybridized. So we know that whenever it is an sp2 hybridized, somewhat double bond character will be present. We know that in order to break single bond, whatever the energy required will be less when compared to break that of your double bond. Or what I am saying is, single bond na break ಮಾಡೋದು ಸುಲಭ, ಡಬಲ್ ಬಾಂಡ್ ನ ಬ್ರೇಕ್ ಮಾಡೋದು ಕಷ್ಟ. ಅದೇ ರೀಸನ್ ಇಂದ ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಈ ಸಿ ಮತ್ತೆ ಓ ಮಧ್ಯದಲ್ಲಿ ಒಂದು ಡಬಲ್ ಬಾಂಡ್ ಕ್ಯಾರೆಕ್ಟರ್ ಉತ್ಪತ್ತಿ ಆಗಿರುತ್ತೆ. ಸೊ ಈ ಬಾಂಡ್ ನ ಬ್ರೇಕ್ ಮಾಡೋದು ಕಷ್ಟ. ಸೊ ಹಾಗಾದ್ರೆ ಈಸಿ ಯಾವ್ದಕ್ಕೆ ಬ್ರೇಕ್ ಮಾಡೋದು, CH3. ಈ ಬಾಂಡ್ ನ ಬ್ರೇಕ್ ಮಾಡೋದು ಸುಲಭ. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ, CH3 ವಿಲ್ ಕಮ್ ಆಸ್ CH3 ಪ್ಲಸ್. ಸೊ ಆ ರೀಸನ್ ಇಂದಾನೆ ನಮಗೆ ಫಿನಾಲ್ ಪ್ಲಸ್ CH3I ಸಿಗುತ್ತೆ. So what is the important note we can write over here? Whenever your, what you can say, benzene containing ethers idre, whenever such ethers are treated with a cold HI, cold concentrated hydrogen iodide, your iodide ion will not attack our benzene ring. Iodide will not attack the benzene ring. Will not attack benzene ring. Instead, it will attack the alkyl group and gets converted to the respective alkyl iodide. One of the important note. Since in this video I am just concentrating on one important reaction only because of this reason. Because ಇದು ಒಂದೇ reaction ನಾವು ತುಂಬಾನೇ ಕಲಿಯಾಗ್ತಿರೋದು. For whatever the things we have seen today, of course, whenever your ethers are treated with a cold concentrated HI, you are going to get a mixture of the product. One will be your alcohol, another will be your alkyl iodide. But if the ether is an unsymmetrical ether, what we saw, your iodide ion attacks the smaller alkyl group, giving your respective alkyl iodide. But if the same unsymmetrical ether is having for example, it is having your tertiary alkyl group, your iodide ion will attack that tertiary alkyl group. When the same ether is treated with a hot concentrated HI, remember, both the products will be their respective alkyl iodide. Is that clear? Okay. Then important note we also came to know, whenever your ether is having a benzene ring, you're going to treat it with a cold HI, your iodide will going to attack our CH3, that is a smaller alkyl group and not the benzene ring. What is the reason? Because there is a double bond character between the carbon which is present in the benzene ring and that of your oxygen. To break this double bond is somewhat greater energy is required, so therefore it is not that much easily possible. Cold condition ಅಲ್ಲಿ ಪಾಸಿಬಲ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ಆ ರೀಸನ್ ಇಂದ ನಿಮಗೆ ಫಿನಾಲ್ ಸಿಗುತ್ತೆ ಪ್ಲಸ್ ಆಲ್ಕಿಲ್ iodide ಸಿಗುತ್ತೆ. Is that clear? Okay, next we will be seeing certain different reactions which are also very much important in point of your exams, PU board exam, and also in point of your CET or NEET. Okay, so in next video we'll be going to see certain other important cleavage of CO reactions. Okay.